Sorry about that. I had students coming in, and sorry about that. Anyway, all right, so if there's a ratio between -1 and 1, that means the geometric sequence is going to converge. Okay, so if you have a fraction that's less than 1, okay, or yeah, it's less than 1, or yeah, it's in between -1 and 1, so like -3/4, 1/4. That means that the geometric sequence is going to converge. Okay, any other number, if a number is greater than 1, or if a number is less than -1, that means it's going to diverge. It's going to split apart and go in whatever direction. Okay, so let's go with number 1. Number 1, if the first term is a to the first power is 3 and the ratio is 4, okay, don't worry about the a1 right in this case. Right here, you just have to look for the 4. Since the 4 is greater than 1, that means it's going to diverge. Okay, it's going to shoot straight up because with every number, it's going to multiply by 4. Okay, but let's go to number 2. Number 2 is the ratio is -3/4. The ratio is -3/4, and because the ratio is -3/4, and because it's greater than -1, it's in between -1 and 1. Okay, it's going to converge. Okay, it's going to converge. All right. So number 3 and 4 you should be able to do. Okay, because it's 0.5 and number 4 is the ratio is 3. Now let's get to number 5. Okay, number 5 is we have a sequence here: 81 plus 27 plus 9 plus 3. All right, and remember how before in the previous video I mentioned how to get a ratio. The ratio is pretty much the second term over the previous term after that, the first term. So it'll be 27 over 81. You can also do 9 over 27 or 3 over 9. All of these fractions add up to, or if you simplify it, it's 1/3. Okay, and so since the ratio is 1/3, what does that mean? That means that the series is going to converge. It's going to get closer and closer to the 0 mark, the x-axis, when you graph it. Okay, let's go to number 9. Okay, number 9 is the sigma to infinity. And k, it starts at 1 and it goes to infinity, the limit. And it's an integral -4 k to the -1 k minus 1 power. When you do something like this, you have to think that there's a form where it's the first term times the ratio, and then n minus 1. There's usually some sort of form to it. Okay. So the first number, the number that's in front is the a1, and in this case, the a1 is negative. Okay, negative and -1, and the ratio seems to be 4. Okay, so the ratio in this case right here, you see this right here, it is 4. Even if it was -4, we would know that it's not between -1 and 1. And since the ratio is 4, or let's say it's -4, because of the negative here, all right, it's going to diverge. Okay, it's going to diverge. All right, next thing here, let's do number 11. Number 11, you see the sigma here, you see the infinite, you see the I equals 11, 4.2, this is the first term, and then this is the ratio at 0.2, and then you see the I minus 1. This is the ratio, the R is equal to 0.2, since the R is 0.2, it's in between -1 and 1, therefore it is going to converge. All right, so hopefully that answers a lot of those questions from at least 1 through 12. All right, now number 13, starting from number 13, you have to use this formula. S is equal to a to the first term over 1 minus r. This is a huge formula. This is the sum of geometric sequences now. Okay, so when you have a geometric sequence, let's say you have let's say you have 8, and then the one we did before, 8, and then you multiply by 2, 16, then 32, and then 64. And you see how you're multiplying by 2 here. If you keep going to infinity, right? If it just keeps going, 128, I think 256 or something like that. If it keeps going, you're going to notice that you can't have a sum. You can't have added total. Why? Because this is going infinitely. All right. So if the ratio is divergent, if it's diverging, there's no sum to it. Okay. There's no sum to it. However, if it's converging, let's say it's let's say it was like one of the ones that were listed here. It was 81, then 27, then 9, then 3. Notice that we're multiplying, multiplying by 1/3. And it keeps getting smaller and smaller. So this is 1, this is 1/3, and this is 1/9, and this is 1/27. And if you notice that these numbers here become smaller and smaller and smaller, it gets so small that even if you get like 1 over 81, those numbers are so small, it's a very small difference. It doesn't really add any value to the sum. So if you have a converging sequence, you can get a sum. Okay, and this is the formula. That formula that I just showed, it was S is equal to 1 over 1 minus R. Okay, so, oh, sorry, not 1 over, it's A to the first, so the first term over 1 minus R. So if you look at number 13 is the first term is equal to 3, and the R is equal to negative 1 over 5. If you plug these in, you'll get the sum. So this equals what? 3 over 1 minus 1 over 5. And this equals then 3 over 1. This is 1 minus 5. Oh, sorry, this is negative 1. Negative. So it'll be 1 plus 1/5, which is then equal to 3 over 1 and 1/5, which is then equal to 3 over 6 over 5. Okay? So when you do that, 3 over 6 over 5, when you do that here, this equals 3 times 5 over 6, because remember, when you're dividing by a fraction, you multiply by its reciprocal. You can cancel this out right here. So this is 2, so the answer is 5 over 2. Okay? Let's do number 16. Okay, 16, and then, yeah, we'll do 16. 16 is, remember the formula is S equals 1 over, the first term over 1 minus R. So the first term is 1 over 1 minus, and the ratio is 1 over 2. This is number 16. So this equals what? 1 over 1/2, right? Because 1 minus 1/2 is 1/2. When this equals 1 divided by 1/2, which is also equal to 1 times 2 over 1, which is equal to 2. Okay? All right? And that's the sum of that sequence. All right? Let's do number 17. Number 17 is 1 plus 0.5 plus 0.25 plus 0.125. Now remember, we have to use this formula, S equal to A first over 1 minus R. We know what the first term is. The first term is 1, so we're going to put that up here. But we don't know what the ratio is. That's what our big clue. That's our big mystery. So what we're going to do is we're going to have to, remember, divide 0.5 over 1, which is then equal to what? 0.5. So the ratio is equal to 0.5. Okay, when you do that, you put that in here, 1 minus 0.5, which is 1/2. That equals 1 over 1/2, which equals 1 divided by 1/2, which is equal to 1 times 2 over 1, because remember the reciprocal, and the sum is 2. All right. Number 25, you're working backwards a little bit, okay? As number 21, remember that the first term is 5, and the ratio is -1 over 5, okay? So you should be able to answer all those questions. Number 25, you're going to be working backwards a little bit. So let's do number 25. S is equal to A first, the first term, over 1 minus R. So what A first term is 1, and then you have the sum of 1.25 equals 1 over 1 minus R. So what you're trying to do is you're trying to find the ratio. Okay? To find the ratio, you have to multiply the quantity 1 minus R to both sides. Okay? Cross that out. 1 is equal to, you distribute, it'll be 1.25 minus 1.25 R. Okay? Then you subtract the 1.25. That comes out to what? Negative 1.25 R equals negative 0.25. Then when you divide by negative 1.25, R is equal to 0.5, I believe. Oh, sorry. 1 over 5, which is 0.2. All right. Hope this helped. Let me know if you have any more questions. We'll go from there. All right. I'll see you later. Bye.